Hello students, welcome you to this session. We are studying matrices and determinants, right? Last class I taught some of the very important things, how to find minor cofactor. You're remembering? So minor means leave the row and column, take the remaining. But cofactor is minor only, but we look into the sign also, right? So we say it is a signed minor, right? The formula given -1 raised to I plus j mij, right? Then we studied some properties of determinant, very important. If two rows are identical, the value becomes 0. If two rows are proportional, again the value becomes 0. Then if you interchange two rows, you have to put a sign minus, right? If you interchange rows and columns, there is no change, right? Like that we study some properties. Okay, now let us do few sums. So look at this question. One determinant given, there is an unknown. What's the unknown? X. Question is solve. Solve means you find the value of unknown. That's all. You have to find X value. So what do you do? Just to expand it, that's all. Expand it and right side is equal to what? 0. Expand, equate with 0. You will get an equation, find X. That's all. So you know how to expand it, right? So 2 into, leave the row and column. 1 into 7. I think now I no need to draw and all, right? Already you studied. 2 into, leave the row column. So 1 into 7. 7 minus 6 2s are 12. Take the second number. When you take the second number, you change the sign, right? So minus x into, leave that row and that column. Are you able to understand? That row and that column, right? So 4 into 7. 7 4s are 28 minus 6, right? 28 minus 6. Next number plus 3 into. Only for the second one you change the sign, right? 3 into. Leave that row, that column. So what do you get? 4 2s are 8 minus 1, right? 8 minus 1 equal to 0. So 2 into minus 5. So minus x into 22, right? Plus 3 into 7 equal to 0. So minus 10 minus 22x plus 21 equal to 0. Take that minus 22x to the right side, it will become plus 22x. Left side 21 minus 10, it is 11, right? So x is equal to 11 by 22. You cancel by 11 table, you are getting x equal to 1 by 2, right? Hope you understood. So like that sometimes there may be two unknowns. X may be appear in two places, okay? Then sometimes you will get a quadratic, solve it, you will get two answers, okay? See the next one. Find determinant AB. Find determinant AB if A equal to one matrix given, B is another matrix, okay? So we want to find determinant AB. This sum can be done in two ways. One, you find AB first. So determinant AB we have to find, right? So for that first you can find A into B. Two matrices given. So multiply the two matrices. You know how to multiply row by column, right? After that, you take the determinant, you will get the answer. Or there is another method. Determinant AB can be written as determinant A into determinant B. Like that also you can do. So matrix A, write it as a determinant. Matrix B, write it as a determinant. Both you simplify, you will get two answers. Both answers you multiply, that's all. So I'm going to teach in both the methods. Let us see whether you are getting the same answer, okay? So first method, you find AB. What is A? 3 minus 1, 2, 1 into B. What is B? 3, 0, 1 minus 2. Matrix multiplication, you know. First row, first column, right? First row, first column. So do very carefully. So 3 3s are 9. Then minus 1 into 1. So minus 1, right? So 9 minus 1. Now first row, second column. First row, second column. 3 into 0, 0. Minus 1 into minus 2. Minus minus plus. So it is plus 2. Now we come to the second row. Second row, first column. So 2 into 3, 6. Plus 1 into 1, 1. Right? So 2 3s are 6 plus 1. Now second row, second column. 2 into 0. It is 0. Plus 1 into minus 2, minus 2. Right? So 0 minus 2. So check the calculation again. First row, first column. It is 9 minus 1. First row, second column. 0 plus 2 Then second row, first column, 6 plus 1, second row, second column, you are getting 0 minus 2. Now just to simplify this, so what do you get? 9 minus 1 is 8, 2, 7 minus 2. This is matrix AB. So we want determinant AB. Matrix cannot be simplified. Don't simplify this one. Okay. So we want determinant AB. So now you write it as a determinant 8, 2, 7 minus 2. This can be simplified. 8 into minus 2, minus 16. Minus 7 2s are 14. So both negative values, so just add it and put a minus sign. So minus 30 is your answer, right? Another method I said, but for the examination you use any one method, okay? For the examination you use any one method. Okay, another method is determinant AB. Determinant AB can be written as determinant A into determinant B. So that is determinant A. What is A? 3 minus 1, 2, 1 into determinant B. What is that? 3, 0, 1 minus 2. Simplify the first determinant 3 into 1. 3 minus 2. So plus 2. Into next one 3 into minus 2. It is minus 6. Minus 1 into 0 is 0. Right? Usual multiplication. 3 plus 2, 5 into minus 6. So the answer is what? Minus 30. So it's very simple, right? Say minus 30, got it. So there are two ways you can use in any one of the method. Now let's go for the next question. Again, solve. We have to find the unknown. What's unknown here? X. You can see X in two places. Okay, so here you have to find X value. Just to expand it, that's all. Take the first number, 7 into, leave the row and column. So 5 into 1, 5 minus 3x. Take the second number, minus 4 into, so leave the row and column. So minus 3 into 1, minus 3, minus x into x is minus x square. It's here already minus, so plus x square. Plus 11 into, leave the row and column, minus 9, right? Minus 9 minus 5x. So you'll get plus 5x equal to 0. So you cannot simplify anything. Just you multiply term by term. 7 5s are 35 minus 7 3s are 21x. Minus into minus plus 12. Minus 4x square, minus 99, right? 11 into 9. Then plus 55x equal to 0. Like terms. So x square only one term, right? So minus 4x square. Later we change the sign and all. X terms you see 55x minus 21x, right? 55 minus 21. So what do you get? 34. So plus 34x. Here then the constant terms 35 plus 12. What is that? 46, right? Sorry, 47. Yes, 47 minus 99 and 47, right? You subtract, your answer is negative. So what do you get? 252. So minus 52 equal to 0. So this is the equation you are getting. First time we want positive, so change the sign throughout. So if you change the sign, 4x square minus 34x plus 52 equal to 0. You change the sign. But still 2 is common. So dividing by 2. Directly you can divide by minus 2. But don't make mistake. That's the reason I'm writing in 2 steps. When you divide by 2, you are getting 2x square minus 17x plus 26 equal to 0. Now, can you factorize it? Sum is minus 17. Sum is minus 17. Product is 2 into 26, what is that? 52, right? 52. Yes, can you find two numbers? If you add, you have to get minus 17. If you multiply, you have to get 52. So 2 table 26. Again 2 table 13. So 13 and 4, right? So minus 4 and minus 13. Check it. If you add these two, you will get minus 17. Multiply minus into minus is plus. 4 into 13 is 52. So split the middle term because the coefficient is not 1. X square coefficient is not 1. So 2x square minus 4x minus 13x plus 26 equals 0. First and second, what is common? 2x, right? Take 2x common, what's remaining? X minus 2. Next to 2, you take minus 13 outside. Minus is not common, but still you take minus outside. So the minus become plus and the plus become minus. So minus 13, if you take outside, you will get x minus 2. If you have a doubt, you just multiply and see. Now take x minus 2 common. What's the remaining? 2x minus 13 equal to 0. So now there are two possibilities. Either x minus 2 equal to 0 or 2x minus 13 equal to 0. From the first you get x equal to 2. From the second you are getting 2x equal to plus 13 or x is equal to 13 by 2. So question is solved. So finally write the solution. Two answers you are getting, x equal to 2 and 13 by 2. So you can write in any order. Okay, so that is solved. These type of questions very simple. Now listen here. Evaluate. So you have to find the value of this. So we study some properties and all, right? So some properties may be useful here. So here what you can do. So this one column you can see as the difference of two numbers, right? The property I said, if one row as a sum of 2, that determinant can be written as a sum of two determinants. It is for row or column. So here for column, instead of plus it is minus. So this can be written as difference of, this can be written as a difference of two determinants. How can you write the two determinants? First column 1, 1, 1 in both the cases. Second column is ABC for both. Third column is, for the first one it is A square, B square, C square, and for the next one it is BC, CA, AB. Minus already we have taken, right? So now let us see. First one I am writing as it is. 1A, A square, 1B, B square, 1C, C square. So it's one of the very important questions, so listen very carefully. Minus. So what I am going to do, first row I am multiplying by A. First row I am multiplying by A. Oh, you know, here something is missing. BC is there. Which letter is not there? A is not there. So first row I am multiplying by A. Second row I am multiplying by B. And third row I am multiplying by C. When you multiply, value should not be changed. So if you multiply, you have to divide also, right? So what we do, multiply R1, R1 means first row, R1, R2, R3 by what? A, B, C respectively. So when you multiply, you have to divide also. Now first row, you multiply by A. First row if you multiply by A, what you get? 1 become A. Then A into A, it is A square. A into BC, it is ABC. So we multiplied, so we divided also. We multiply by A, yes, by A we divided also. Second row you multiply by B. So 1 into B, it is what? B. Then next will be B into B, it is B square. Then CA into B, CAB, or you can say ABC, right? So we divided also. You multiply by B and divide by B. Third row you multiply by C. If you multiply by C, 1 into C, it is C, C into C, C square, AB into C, it is what? ABC. So we multiplied and divided, so there is no change. First determinant, nothing, just we are writing as it is. In the second determinant, first row you multiply by A, so outside you put 1 by A. Second row you multiply by B, so outside you put 1 by B, because if we multiply you have to divide it. Third row you multiply by C, outside you put 1 by C. So all that 1 by A into 1 by B into 1 by C only we are writing it as 1 by ABC. Are you able to understand? And now you see, first one there is no change at all. 1A, A square, 1B, B square, 1C, C square. Minus. In the second one, 1 by ABC already we have. Now we see the determinant. See the third column. They are all same, right? One of the very important difference between matrix and determinant. In a determinant, if something is common in any one row or in any one column, you can take it out. So in the third column, ABC is common. Take that ABC outside. So what happens, you know? First column, no change. Second column, no change. That column, that A, B, C, we have taken out. So nothing left out. That means you write 1, 1, 1. Are you able to understand it? Now this ABC, ABC cancel. Now see, just two determinants we have. Both almost look similar, no? 1A, A square. Then one property I said, if you interchange two rows or two columns, you have to put a sign minus. 2 times if you interchange, there is no change, right? So 2 times interchange, that only cyclically rotate. Please listen, here 1A, A square, 1A, A square. Suppose if you start with A, see the order, 1A, A square, again 1, right? So 1A, A square. If you start with A, after A square, then 1. If you start with A square, 1A. You can start in any way. So you see this, here we have 1A, A square, 1A, A square. If you start with A square, 1. So both are same only, no? Yes. So you can rewrite them. So how can you write, First one you write as it is. 1 means that column fully 1. Then A, that is ABC. Third column is A square, B square, C square. Minus. This one cyclically I'm going to repeat. We want to rotate it. So we start with 1. Why do you want to start with 1? Because the first one started with what? 1. So here also I want to start with 1. A square, 1. That is the order we have. A square, 1. A square, 1. If I start with 1, then after 1 you write A square, right? 1A square. 1 means that column fully 1, 1, 1. A means below A, what do you have? ABC. A square below A square, it is B square, C square. So columns cyclically we are rotating. So now both are same. It is like 5 minus 5, right? So your answer is 0. Are you able to understand this? So these are some of the very important questions. So practice well. Now look another question. Prove that equal to 0. So here given the answer, they asked to prove this is equal to 0. We start with LHS. What is LHS here? 1 by A, 1 by B, 1 by C. First column, right? 1 by A, 1 by B, 1 by C. Then you have BC, B plus C, CA, C plus A, AB, A plus B. What answer you are supposed to get? You are supposed to get what? 0. When you will get 0? Sometimes when you expand it is 0. Using some property we study, In 2 cases, your answer may be 0. So when 2 rows are identical, exactly same, the answer is what? 0. Or one row and is proportional to another one. Proportional means some multiple, right? Again the answer is what? 0. Let us see what happening here. Like previous question, what is missing here? BC we have. So what is missing? A. Here what is missing? B is missing. Here what is missing? C is missing. So like previous question, you multiply first row by A, second row by B, third row by C. If you multiply, you have to divide also. So now that the same step we are going to use here. Okay, so multiply R1, R2, R3 by what? A, B, C respectively. Meaning first row you multiply by A, outside you put 1 by A. Second row multiply by B, outside you put 1 by B. Same way third row by C, outside 1 by C. So everything together, outside you write 1 by ABC. Hope you understood. Now first row you multiply by A. See, every time you multiply by A. When you multiply first term by A into 1 by A. A cancel, right? A into 1 by A. A cancel. So what you get? You get 1. Then next you multiply by A, you will get ABC. Next one you multiply by A, see what you get. If you multiply by A, multiply term by term, AB plus AC, right? AB plus AC. So first row you multiply by A. Second row you multiply by B. So first term, B into 1 by B, cancel 1. Second term, if you multiply by B, already CA is there. If you multiply by B, CAB, write in order ABC, right? Third one, you multiply by B. Third, multiply by B. So BC plus BA. BA or AB. Okay. Third row you multiply by C. Tell me quickly. Third row you multiply by C. C cancel. You are getting 1. Multiply by C. ABC. Third row multiply by C. Third final element. Last element. Multiply by C. AC plus BC. Right. Now you see what can you do. 1 by ABC is there. Can you take something outside? Yes. The second column. What is common? ABC. Take that ABC outside. So what is left out? First column 1, 1, 1. Second column ABC you are taken out. So you are getting 1, 1, 1. Yes or no? Yes. Then the third column AB plus AC. BC plus AB. AC plus BC. Now this ABC cancel. So what you are getting now? 1, 1, 1. Again 1, 1, 1. Then AB plus AC. BC plus AB. AC plus BC. You know the answer is 0. Why? Because C1 equal to C2. Two columns are identical. Write the reason correctly. This is not row, column, right? Which column? First column and second column. They are identical. So they are equal. So the answer is 0 and that is RHS. Okay. So hope you understood this. Okay. Now let's go for the last question in this exercise. Prove that one determinant given. See the right side. 4a square b square c square. Even if you expand directly, you will get. If there is no other way, you do that, right? But let us see some easy method. We start with LHS. What is LHS? Minus a square, AB, AC, AB minus b square, BC, AC, BC minus c square. So what answer you are supposed to get? 4a square, b square, c square. Let us see. In the first row, can you see something common? First row, what is common in all the terms? A is common. Second row, what is common? B is common. Third row, what is common? C is common. If something is common in one row, you can take it out. So first row, you take A outside. Second row, you take B outside. Third row, you take C outside. So write the steps. So taking A, B, C outside from R1, R2, R3 respectively. Meaning from the first row you take A outside, second row you take B outside, third row you take C outside. So listen, see what you get. So this is first row I am taking A outside. So what is left out? Minus A, right? Minus A. A you are taking only B and only C, because from the first row, from every term you take A outside. Second row you take B outside. So B you are taking outside, so you get only that A. Minus B square, you take one B, so still one more B. Then B you take out C. Third row you take C outside. So C if you take outside A, B minus C, right? Still you can see something common, no? First column, what is common? A is common. Second column, B is common. Third column, C is common. So, again you taking A, B, C outside from what now? Now not rows, column, right? From C1, C2 and C3 respectively. That means already you have ABC. Now, from the first column, you take A outside, second column B, third column C. Tell me what's the remaining. First column, you take A outside. So, remaining minus 1, 1, 1. Second column, you take B outside. So, 1, minus 1, 1. Third column, take C outside. 1, 1, minus 1. Now, all small numbers, right? Just you can expand it. So, see, when you multiply these two, what you get? A into A square. B into B, B square, C into C, C square. The answer also we need that, no? Yes, A square, B square, C square, you got it. Now still one more, what do you need? 4. So that means the determinant part, when you expand, you will get 4. Let us see. Take the first number. What's the first number? Minus 1 into, leave the row and column. Minus 1 into minus 1. 1 minus 1 into 1 is 1. Take the second number, you change the sign, minus 1 into. Leave that row, that column. 1 into minus 1. Minus 1. Minus 1 into 1 is 1. Take the third number as it is, 1 into. Leave that particular row, that particular column. Remaining you simplify. 1 into 1. 1 minus. 1 into minus 1 is minus 1. So minus into minus is plus 1. So you simplify this a square, b square, c square into 4, right? But don't write directly. You check it. Minus 1 into 1 minus 1, 0. Minus 1 into minus 2. Minus 1 minus 1 minus 2 plus 1 into 1 plus 1 is 2. So that is a square, b square, c square. Minus 1 into 0. It is 0. Minus into minus is plus 2. 1 into 2 is 2. Now 2 plus 2 is what? 4. So you are getting 4 into a square, b square, c square. That is RHS, right? This is what they asked to prove. 4a square, b square, c square. So it's a very simple topic only. But since the beginning, so I thought of taking very slowly. Okay, so we did all the sums. Your work, you have to work out the example sums. Okay, so now let us see the next one. First, let me teach some definition, and if time permits, few sums. Then next class we continue the remaining. Okay. Listen, two definitions you have to study here. Singular and non-singular matrix. Suppose a square matrix is given. We want to check whether this matrix is singular or not. So with the matrix, you cannot do anything. Okay, so to check the matrix is singular or not, with the matrix, you can't do anything. Suppose they are giving a matrix, say 2, 1, 5, 3. So I want to check whether this matrix is singular or not. It must be a singular, it must be a square matrix. So for that, what do? No? You find the corresponding determinant. You find determinant A. Matrix cannot be simplified, right? So convert it into a determinant. So determinant 2, 1, 5, 3. Determinant can be simplified, right? So 2 3s are 6, minus 5 into 1 is 5. The answer is 1. It is not equal to 0. If you get 0, the given matrix is singular. If it is not equal to 0, the given matrix is non-singular. So here it is not equal to 0. So what you can say, the given matrix A is non-singular. So now tell me, how can you check whether the matrix is singular or not? First you see it is a square matrix or not. If not, you say we cannot check this. Why it should be square matrix? Because we are converting into determinant. Determinant must be a square. Already I taught, right? So only for square matrix you can check whether it is singular or not. How can you check it? With the matrix you cannot do anything. Convert it into a determinant. Simplify. If your answer is 0, the matrix is singular, not the determinant. Given matrix is singular. If the determinant value not equal to 0, the given matrix is non-singular. Here it is not equal to 0, so non-singular. See the definition? Singular matrix. A square matrix, it is important. A square matrix A is said to be singular if determinant A equal to 0. For singular, determinant A equal to 0. A square matrix A is said to be non-singular if determinant A not equal to 0. Okay, the definitions you study. And here also they'll ask some questions. They give some matrix, they'll ask you to check whether it is singular or not. Some times what they do, no, they give a matrix. Somewhere they put some x, some unknown. They will ask you to find x value, and what condition they give, it is singular. It is singular means what can you say? You convert it as a determinant and you put equal to 0. Then solve. Earlier we did like that. So instead of giving equal to 0, they say it is singular. Singular means the determinant value is equal to 0, right? So that type of question they can ask. Okay, now one of the very important thing I am going to teach. I think all of you know how to find cofactor. That's one of the very important area. Cofactor. Suppose a 3 by 3 matrix is given, determinant is given. Find the cofactor means a lot of things you have to do, right? For all the 9 elements, you have to find the cofactor. But what is cofactor? Signed minor. For 3 by 3, you know how to mark the sign. Plus, minus, alternately you mark. Then you write the minor, okay? So, next what I'm going to teach, adjoint of a matrix. So we are going to teach adjoint of a matrix. I'll tell you what it is. After that, I'll give the definition. Please listen here. Suppose a matrix is given. A matrix is given. To find adjoint of a matrix, you find the cofactors. You find the cofactor of every element. So that is, you find C11, C12, C13, C21, C22, C23, C31, C32, C33. Already I taught how to find the cofactor, right? It is 3 by 3. If it is 3 by 3, plus, minus, plus, minus, plus, minus, plus, minus, plus. How we are getting already explained, right? Suffix you have to add it. If it is odd number, minus. If it is even number, plus. Minus 1 raised to I plus j. Okay, so basics you study, but for exam, every time you don't need to check all those things. You know, 3 by 3. So this is the order you have to put. Now after this, you attach what? Minor. Leave the row and column, you get some number. Okay, that you write. So okay, so by that, you can simplify all these, right? So now, you know the cofactor of all the 9 elements. Now using this, you form a matrix called cofactor matrix. You form a matrix called what? Cofactor matrix. Cofactor matrix. The name itself, it is there. Cofactor matrix, that is you replace every element by the corresponding cofactor. And we denote it as Aij. This is called cofactor matrix. What you do now? Don't write the first element. Instead of that, you write its cofactor. We got the answer here, right? So you write all these cofactors. First cofactor, second, third, 4, 5, 6, right? All the cofactors what you got here. Okay, what you got all the cofactors, no? You write one by one. That is, you are replacing every element of the given matrix by its corresponding cofactor. So this matrix is called what? Cofactor matrix. But we want to find adjoint of A. Adjoint A, in short, we write ADJ. Adjoint of a matrix, we denote it as what? ADJ alone. ADJ. You read it as adjoint A. Adjoint A. Adjoint A means Aij transpose. What is Aij? Cofactor matrix. Just you got it, right? It's transpose, that's all. So how can you find the transpose? First row, you write it as first column. Second row, second column. Third row, third column, that's all. So how can you find adjoint of a matrix? Tedious work, lot of work is there. First you find all the cofactors. Form cofactor matrix. How can you find cofactor matrix? Replace the element by the corresponding cofactor. Then you take transpose of that. That is very easy, right? Interchanging rows and columns, you will get adjoint A. So for adjoint A, find the cofactors, form cofactor matrix, take transpose. Okay, so that is called adjoint of a matrix. So now look at the definition. Adjoint A is equal to Aij transpose. What is that Aij? Is a cofactor matrix. Okay, so this is the procedure you have to do. You know how, nothing new to teach. Already you know how to find cofactor. Now only thing, write all the 9 elements, you write in order. Then take transpose, that's all. 2 by 2 also same thing, but there is some easy method for 2 by 2. I'll teach that one. Please listen. Let us see. So you find the cofactors one by one. C11, C12, C21, C22. So here the sign you are remembering, plus, minus, minus, plus. Even if you forget, don't worry, add the suffix. 1 plus 1, 2, plus. 1 plus 2, 3, odd number, minus. 2 plus 1, 3, odd number, minus. 2 plus 2, 4, plus, right? So now first one, leave the first row and first column. Leave the first row, first column. So what do you get? D, right? So it is plus D. Next one, for the second one, leave that row and that column. So you are getting what? C. Then for the third one, leave that row and that column. You are getting what? B, right? And the last one, D. Leave that row and that column. So what do you get? A. So all the cofactors, you got it. So form a cofactor matrix Aij. Cofactor matrix is D minus C. You write in order. D minus C minus B, A. This matrix we call it as what? Cofactor matrix. So we want adjoint A. So adjoint A means it is Aij transpose. You take transpose of this. How can you take transpose? First row, you write it as first column. What is the first row? D minus C. Second row, minus B, A. So this is your answer. But now I am going to teach one easy method for this 2 by 2 alone. From here, How to get this directly? Just two changes. Principal diagonal. You know what is principal diagonal? The principal diagonal elements interchange. What are the principal diagonal elements here? A and D. Interchange. That is D you write there, A you bring here. Principal diagonal. This is only for 2 by 2. Okay. So A, D, you write it as D, A. Other two elements. What are the other two elements? B and C. Let it be there. You change the sign. So you get minus B minus C. You got the answer. D minus B minus. That's all. Two changes. What two changes you have to make? Principal diagonals interchange. And for other two elements, you change the sign. So listen one example. Let us try direct method. Suppose B is a matrix, minus 2, minus 7, 4, 6. I want adjoint B. Directly adjoint B. We are not finding cofactor matrix and all. For 1 mark, you do like this. For other sums, for checking, you can do. Okay, otherwise, better write the steps. So what do you do? Suppose it's a very lengthy question. This is one step. Then you do directly. Okay. Principal diagonal interchange. What's the principal diagonal? So this you have to interchange. So minus 2, 6. So you write 6 here and minus 2, 6, minus 2. Other two elements, you change the sign. What are the other two elements? Minus 7, you write it as plus 7, and 4, you write it as what? Minus 4. So minus 7, you write plus 7, 4, you write what? Minus 4. Are you able to understand? Listen, one more sum you see. Suppose C equal to 1, 7, 2, 6. What is adjoint C? Principal diagonal interchange. 1, 6, you write 6, 1. Other two elements, you change the sign. 7, you write minus 7. 2, you write minus 2. If it is 0, you write 0 only, minus 0. Same thing, right? Okay, so almost you finished. Just I'm giving these properties alone. Just you go through and you can learn this. So, determinant adjoint A. These are some of the properties. Determinant adjoint A is equal to determinant A raised to n minus 1. Okay, that's all. Well, what is n they mentioned? N is the order of the matrix. Determinant adjoint A is determinant A raised to n minus 1. N is the order. Suppose if it is a 3 by 3, 3 minus 1, it will become determinant A square. For objective questions, it is important. Okay, so that is the first result. Second one, determinant Ka. So here n is the order. Okay, n is the order of the matrix. So your answer is k raised to n. K raised to n into determinant A. Adjoint Ka. So determinant Ka, adjoint Ka, you have to be very careful. N is the order in both the cases. N is the order. Like 3 by 3, we say n by n, general. Okay. So when determinant comes, it is k raised to n. When adjoint comes, k raised to n minus 1. Because adjoint means cofactor we take. One row, one column, we leave it. So if it is a 3 by 3, if you leave one row, one column, it becomes 2 by 2, one less. So in adjoint, 1 you have to subtract. Okay. So when you find determinant A, the constant become constant raised to order. Order is n, so k raised to n. If the order is 3, k raised to 3. But when you find adjoint, if the order is n, k raised to n minus 1. If the order is 3, k raised to 2. You reduce one power for adjoint. The reason is when you take adjoint, we take cofactors. Cofactor means you leave one row, one column, we take the remaining only. If it is a 3 by 3, if you leave one row, one column, it becomes 2 by 2, right? So order become reduce 1. Next result, very important for verification. So next class we'll do sums using all these. Okay, so you have to prepare. That's the reason I'm giving now. A into adjoint A equal to adjoint A into A equal to determinant A and I is very important result to verify. So you find all the three. We prove all the three are same. Adjoint of identity matrix is identity matrix itself. Adjoint of AB. Reverse order you should write. Adjoint ABs. AB transpose, you know. What's AB transpose? B transpose, A transpose. Then same way, adjoint AB is adjoint B into adjoint A. Reverse order. Okay. So determinant AB is determinant A into determinant B. Today we used. Okay. In one sum we used. So that's all. You prepare all these things. So next class we are going to study another very important result. How to find inverse of a matrix. Okay. We'll see you in the next class.